Okay, the last thing we're going to do to wrap up lecture 16 is to use the find function with row column indexing instead of linear indexing. And this will let us pull out the lengths and the widths that give us the areas that satisfy our condition that the areas need to be divisible by 3. Okay, so let's again create a new cell, clear CLC, and reload our data file. This time I'm going to copy and paste. Okay, so let's run this section and look at our areas vector again. Okay, so with row column indexing, we can make some notes here. So the 10 is in row 1, column 1. Oops, that's a 2. Okay, let's try that again. Okay, so the 10 is in row 1, column 1. Okay, the 15 is in row 1, column 2. The 20 is in row 1, column 3. Okay, perfect. The 12 is in row 2, column 1. The 18 is in row 2, column 2. And then finally the 24 is in row 2, column 3. Okay? Now, the find function is overloaded so that we can, instead of requesting a single output like we did up here where we assigned the output into our variable lim indices, we can instead ask for 2 outputs, and it will give us the row values and the column values of the values that meet our condition. Okay, so again, we call the find function, and in the parentheses we type our condition. So the remainder of areas divided by 3 is equal to 0. Close the parentheses. Okay. And so MATLAB, as it does this, is going to, as we should be getting used to, start here at the 10, go down, up and over to the 15, down, up and over to the 20, down. Okay? And then it's going to pull out the row numbers and the column numbers. Okay? If the condition is met. So it starts with the 10, condition is not met, it's not divisible by 3, right? It goes down to the 12, it is divisible by 3. So in the row variable, it's going to put row 2, and in the column variable, it's going to put column 1, okay? Then it's going to come up and over to the 15, the condition is met, so it's going to take this 1, the row number, add it to row. It's going to take 2, the column number, and add it to our column variable. It's going to come down to the 18, also divisible by 3, so it's going to grab the 2, add it to row. This is also a 2, the column is 2, so add that to our column variable. Up and over to the 20, condition is not met, so it does nothing. Down to the 24, condition is met, so it's going to take the row number and add it to our row vector, and the column 3 and add it to our column vector. Okay, so I'm predicting that we're going to get a column vector, our row column vector is going to have values 2, 1, 2, and 2, and then our column vector is going to have 1, 2, 2, 3. Alright, so let's run this and see if that's what we get. So run section. Uh-oh, and we have a problem because I forgot the 0. I don't know how I did that, and you guys weren't here to help me with that. Alright, so let's try again. And row 2, 1, 2, 2, just like we thought, and call 1, 2, 2, 3, again, just like we thought. Okay, so great. Now what we want to do is use those row and column vectors to pull out the lengths that correspond to the good areas. So we're going to call those the good lengths. Okay, so we want to basically index out of a vector of lengths and index out of a vector of widths, but we don't have those, right? So that's a little weird. So the first thing we're going to do here is create a vector of lengths. So now we have to go back and remember what our area's vector was all about. So possible lengths of 5 and 6 in rows 1 and in row 1 and row 2, and possible widths of 2, 3, and 4 in columns 1, 2, and 3. Alright, so we can come down here and create a vector. Let's call it all L's. So all L values. So the possible L values are 5 and 6. Okay, and then we will index out of all L's with our row vector that we created, right? Because if we go back up here and look, it says that a length of 5 is in row 1 and a length of 6 is in row 2. Okay, so we'll index with our row vector and we will assign the output of that indexing into a variable called good L's. Alright, so let's think about that. Our row values are 2, 1, 2, 2. So the length of the second row is 6, so we should get a, I guess let me write that. We should get a 6 for the length when the row is 2, and another 6 and another 6, right? And then if the row is 1, that length should be 5. Okay? So let's run this and see if that's in fact what we get. Now, since we are indexing out of a row vector, the output is also going to be a row vector, okay? So let's run this and then take a look. Okay, so here we go. We're going to run section. So all L's, 5, 6, we made that a row vector, and so good L's, here are our values, 6, 5, 6, 6, just like we thought, 6, 5, 6, 6, but it's a row vector because all L's was a row vector. Okay, now we can do the same thing with the widths. Before we can index anything, we have to have a vector to index out of, so let's create a variable called all W's, and the possible width values are 2, 3, and 4. Okay, so again in columns 1, 2, and 3. So if we want the good W's, the good width values, we'll index out of our new all W's vector with the column vector that we got from the find function. Okay, so now the column values are 1, 2, 2, 3. Column 1 corresponds to a width of 2, so we should get a 2. Column 2 is a width of 3, and then another 3 here because the column is 2 again, and then column 3 is a width of 4. So our good W's vector should have the values 2, 3, 3, 4, but again, since we made all W's a row vector, good W's will also be a row vector. So despite the fact that I'm writing a column here, we're going to get a row. Alright, so let's go ahead and run that section and confirm. So all W's 2, 3, 4, and good W's 2, 3, 3, 4, which matches our prediction of 2, 3, 3, 4. Alright, great. Thanks for watching these videos, and I hope you enjoy Homework 8.